Hi folks, so the question we have in front of us here today, guys, is a sample question from the DCG workbook, sheet 12. It is one of the sample questions at ordinary level. So the question says, the map shows ground contours at 10 meter vertical intervals. Our scale is 1:1000, so that's important there. Therefore, the distance 90 down to 80, so we can see it's obviously 10 meters in between the contours. Scale is 1:2000, 1 millimeter in reality. 1 millimeter on my sheet is equal to 1000 millimeters in reality. Therefore, to work up to 10 meters, I'd multiply that by 10. So 1000 millimeters is obviously 1 meter multiplied by 10 to make 10 meters. Therefore, 10 is kind of like our little magic number we'll be using. Now, on the map, draw a vertical section profile along the line XY. So we can see we have a cutting section here, a vertical cutting section that is going through our contours all the way to the 110 roughly. And we have to draw a profile here for that. And it also says vertical boreholes are drilled at A, B and C. So they're going straight down A, B and C. These hit the head wall of a stratum of ore. Okay, so they're hitting the head wall of a stratum of ore at altitudes of 100, 90 and 80 respectively. So what that means is A is at 100, B is at 90 and C is at 80. The borehole at B hits the bottom of the stratum, so that's the footwall of the stratum at 82. Determine the strike dip in thickness, so that's why we needed obviously the footwall of the stratum where it hits there as well, so that'll help us get the thickness later on. But starting off, it says on the map draw the vertical section profile, so that's what we're going to start with. So I'm just going to look at my contours here. I'm not going to focus on this stratum of ore for now, but I'm just going to focus on the XY line here, which is the cutting section, and we can see it goes from 90. I'm just trying to see what the lowest one is. Okay, so we can see it's 100 or 110, sorry, 110. Just looking at this one, it's 120, 110, 100, 90, 80, 70. So 70 is probably our lowest one, okay? So with that in mind, what we're going to do is we're going to measure up in distance of 10 millimeters. And I like to do it from the top line here. So just thinking 70, 80, 90, 100, 110. Goes up to 120. Just looking where the 120 is. Yeah, that looks like it's going to fit there. So I'll just put those in. 70s, 80s, I'm going up to 100. So 70, 80, 90, 100. Yeah, that'll just about fit. 110. Yeah, I might actually start a bit lower. Okay. So there we have it. I've made my little marks there. So that'll be 10, 20, 30, 40, 50, 60. Okay. And starting here, I'm going to imagine it is starting at this one. Project across. Okay, just projecting across what will be seen as my contours when I'm looking at them in the elevation view. Okay. You can see the writing is slightly got in the way up here, but I don't think I'm obviously going to have to need it going the whole way across, so I'm just trying to keep it neat and tidy. I'm going to start my 70 down here. Okay, therefore making this 80, 90, 100, 110, and this one 120. So I didn't need the top one there. Okay. And starting off where the XY line cuts the contour, so you can see here it cuts the 90 contour right there. At that point there I'm going to project it up as far as the 90 height, and likewise with the rest of them. So 90 is up to there, this one is at the 80, this one is at the 70, which is right here, likewise here with the other 70, then we're going back up to the 80, 90, this one is 100, you can see the 100 is there, this one is at the 110, then we have two of 120, and 120 again, because the 120 dips down and it came back around, and then finally we have the 100, sorry, the 110, apologies. Okay, you can see our kind of points all along there. So what I'm going to do is I'm going to sketch in that there, so I'll just speed up the video while I sketch in the vertical section profile. Okay, so there we have it. That is the vertical section profile along the line XY there. As you can see here at the 70 and the 70, and then another example up here at the 110 and the 110. Because I was going down, it's not just going to go straight across 70 to 70 as a straight line like that. Chances are, because it's going down, it's going to follow the lay of the land. As it's going down, before it comes back up, it's going to dip. And likewise up here, it was going up, and then it's going to go down, depending on the direction where it's going after that, okay? So that's why you just dip it a little bit below and a little bit above the lines here, okay? Now, the next part of the question, it says, on the map, or sorry, part B, it told us after the vertical boreholes, determine the strike, dip and thickness of the stratum. Okay, so what we're going to have to do is we're going to have to locate points A, B and C. This is the plan view of our stratum of ore. We also have to find the elevation view because we need the elevation to determine our strike. Okay, so locating point A. And remember, respectively, so A is at 100, so I can project that up to the 100 mark from A, just there. B is at 90, so I might have to project these out just a little bit further. And what I can do is, where my 90 contour is, I can project that across. And finally, C is at 80. So there's my 80. So there we have it, locating A, B and C, and likewise they drew it in plan, so we must also connect them in our elevation. So what we've actually got here is the elevation view of that stratum of ore, okay, which is a plane surface. Okay, this is the plan view of it, this is the elevation view of it. And what we need to do first of all is determine the strike. Now the strike is a line, it is a level line running across that stratum of ore, okay, a level line. And what we're going to do is we're going to do a level line parallel to the XY line. We're treating this as our XY line, and we're going to do a parallel line to that. So I'll actually put that in heavy. Okay, where that cuts from B, we do it from the middle one, okay. From B, we do a level line parallel to the XY line. Where it cuts AC right there, what we're going to do is project that down to locate it in our plan view. And it'll connect up there. And we will also connect that across. So from there, over to B. Okay, and that there is our strike. Now that strike line is the exact same as this line up here, but obviously you can see this one up here is parallel, okay, to the XY line. We're treating this as our XY line. Now I know we had an XY line here which is treated as a cutting plane, but if you think of just orthographic, usually elevation up here, our plan down here, XY line, okay. And that line there is our strike line as well. That is the elevation view of this line, but this is the one that we need because that actually is a true length, okay. The reason it's a true length is because any line that is parallel to one of the principal planes, okay, in one view, that makes it a true length in the other. So because it is parallel with the XY line in the elevation, therefore in my plan view, it is a true length. Okay, now what we're going to do is, having found the strike, I'll just take that off, I found my strike, the next one I have to find is the dip. And the dip is the angle that that ore makes with the ground, okay? So obviously the ore isn't always going to be level, it's not just going to be flat underneath the surface, it might be at different levels, okay? And what we have to do is we have to find the level that it's at and the angle it is at, okay, which is known as the dip. So to do that, what we need to do is we need to look out along our strike to see it as a point view, and because the strike is on this surface, we'll actually see the surface ABC as an edge view. So what I'm going to do is project out parallel with my strike, and I'm going to set up an X1, Y1 perpendicular to that. So just a little bit of sliding set squares here. So line it up with the strike line, rotate it around, slip a little bit there. Come back on anchor. There we go. Rotate it around and set up my X1, Y1. Both here. And that there is my X1, Y1. Okay, and just determining C was at 80, B was at 90 and 100. So I'm going to start, this X1, Y1 is going to start for me at a height of 70. Okay, so measuring out along this line, 10 millimeters will bring me up to 80. Another 10 millimeters, which is 10 meters, that'll bring me up to 90. And then finally, final one will bring me up to 100. Okay, so I'm going to put those contour lines in on my auxiliary view, which is what this is. So that'll be my 80. This will be my 90. And finally 100. So I can write those in as well. 80, 90, 100. Okay, now what I want to do is I want to find A, B and C. Well, B already I know is up a height of, is at 90. Okay, so I know B is going to be right here because it's on the 90 contour. So technically this would be B1. Okay, so there's my B1. Now, I know C is at a height of 80, so once I project it out C, perpendicular to the X1, Y1 or parallel to my strike. Okay. That's where C is going to be, and likewise with the A point, that is going to be at the 100. So there's my C1 and A1. Okay. And what I do then is I connect all of them up, and what we should see them is as a line. Okay, and depending on your accuracy, hopefully they all line up. And this is seeming to work out for me. I'm actually quite happy with this. There we go. Okay, so there's my points A, B, C, and if I was to extend that on, I'll do it lightly and extend down my X1, Y1. Don't have to, but the angle that is created inside in here, that angle in there, is my dip, which is often signified by that symbol there. Okay, or you could just write dip. Okay, so there we have it. Now we've got the dip, so I'll tick that guy off. Okay, and the very final one is it wants us to determine the thickness of the stratum of ore. Now, in any time you have the layer of ore, there's going to be a head wall and a foot wall. Okay, and the area in between the head wall and the foot wall is going to be the thickness, and that's how much basically material that you have, be it the gold or the coal or whatever it is the miners are searching for. What they did tell us previously in the question, it said was vertical boreholes drilled at A, B and C, these hit the head wall. Okay, so A, B and C are on the head wall. Okay, so that's very important to note there. This is actually the head wall. Okay, so that's the top surface. It also says the borehole at B hits the bottom surface of the stratum at a level of 82 meters. Okay, so therefore from B, okay, remember this is 80, this is 90, and it was 10 millimeters in between, so 82 millimeters would be simply a case of adding on an extra 2 millimeters on our sheet, but that would actually be 2 meters in reality. So what I'm doing is I'm measuring back 2 millimeters here from the 80. Okay, so I'll actually just do it this way. So from the 80 contour from here, I'm going to measure, because it's out along B. Make sure it's accurate. Measure out 2 millimeters right there. And that point right there is a point on the footwall, okay, of the stratum of ore. Now, once we have a point on the footwall, and because we have the head wall, we know that the stratum of ore, okay, the head wall and the footwall are always parallel. So from there, what I can do is I can actually determine the footwall. There's my footwall because it's parallel with the head wall. So I'll write in footwall. And what's important to note is that we actually, the perpendicular line between them, that space inside there, I'll actually put it in dark, but that space inside there, okay, is the thickness, T. Okay, so there we have it, that's our thickness. And finally, I can take him off as well. Okay, so there's a little bit in that, just the understanding obviously of the dip, the strike, the strike, the dip, and determining the thickness. Okay, but as long as you're able to do that, it'll never change in any other questions. Okay, just on maybe how they word it to you and so forth. Okay, hope you found that helpful, guys. There's another question at the bottom page which I'm going to move on to now. Okay. Right, folks, so the next question we have on this page, it says, question 2, the map shows ground contours at 5 meter vertical intervals. Our scale is 1:1000. Okay, so 5 meters, so 1 millimeter on our sheet is 1000 millimeters in reality. We know 1000 millimeters is 1 meter. We want to work up to 5, so it's literally, our magic number is kind of 5. Okay, now It says on the map, draw a vertical section profile along the line XY. So we can see the line XY going across our contour lines. Okay. It also says an 8 meter deep lake is located at position C. Okay. On the profile, draw the water level of the lake. Now it doesn't say show position C on your sheet, but position C is essentially the lake is going to be here. Okay, at this section down here. Okay, so that's position C in there. All right. It also says a scenic picnic spot is to be placed at Z on the profile. Can the lake be seen from this spot? In your opinion, is this a good position? So we'll figure out that in a bit. And then part C, AB is the central line of a proposed roadway which is level at an altitude of 50. Okay, so that roadway there is level at an altitude of 50 meters. Using side slopes of 1 and 1 for cuts, complete the earthworks necessary to accommodate the roadway. Okay, so I'd imagine there is obviously some lake down here, picnic up here, so obviously the road is leading down to the lake and so forth, and it stops at a certain point. Okay, so I'd imagine that's the idea. But starting off, part A, on the map, draw a vertical section profile along the line XY. So looking at our contours, just to determine, I can see here that the lowest is 35 and the highest, we can see it's dropping from 80 down to 35. Okay, so it's quite a good section of points in here. So I'm going to start, if the lowest is 35, I'm going to start here at 30. Okay, and from there I'm going to measure up distances of 5 millimeters. Okay, to determine our contour lines, because our distance between our contours is 5 meters and our scale is 1:1000. So if this is at 30, then up 5 millimeters will be 35, 40, 45, 50, 55, 60, 65, 70, 75, up to 80. Okay, so plot in those contour lines as they would appear in an elevation view. Okay. Okay, and I am going to write in the heights: 35, 40, 45, 50, 55, 60, 65, 70, 75, and finally 80. Okay, so we've done this before, so literally it's just a case of locating the point. So at this one here, I can see it's at 80, so just take a note: 75, 70, and so on. Okay. So this one here is at the 80, it's up to the top. Position Z, this one's at 75, 70, 65, next one is at 60. Okay, just making sure I'm still on the 60, yeah, okay. Then we're down to, just making sure, 60, and the next one, sorry, yeah, was 55, which is where I was going, yeah. So to be 100% accurate as I'm doing it. And then we had 50, and just making sure 50, yeah. Okay, after 50 went back up to 55. I'm following it down here. It goes up to 55. Then this one goes up to 60. The next one goes up to 65. And the next one is downwards again to 60. Then we're 55, 50 for the next two. So 55. And then this one is 50. And then we're at 45 for the next one. Next one's at 40. Then we have 35. And and once again 35, and it's working back out now, 40, and then finally 45. Okay, so you can kind of see the profile of it there. So I'm quickly going to sketch that in, so I'll speed up the video. Okay, so there you have it. That is the vertical section profile, slicing through the mountain along the line XY. So that's part A done. Part B, it says an 8 meter deep lake is located in C. So C is kind of this section here, which is basically the valley. Okay. It says a scenic picnic spot is placed, that said on the profile. Okay. Can the lake be seen? So first of all, we have to put that lake in. So it's an 8 meter deep lake. So from the lowest part of the lake, which is roughly here, we're going to measure up 8 millimeters, okay, which equates to 8 meters. So 8 millimeters. So 1, 2, 5. So 8 meters is right there. I'm going to put this in with a blue line. It should probably appear black on the screen, but there we have it. Okay. So that section there, I'm going to just put a little bit of hatching in there. Okay, that section there is our lake. A little bit further. That's our lake right there in position C. And what they're asking is, can it be seen from point Z? So if we follow up Z, Z is right there. Okay, so if you imagine there's a little picnic table there, can it be seen from that position? So using line of sight, okay, from Z, looking to the furthest point of the lake, no, because essentially if I was to do a line like that, and I did it to the furthest point of the lake roughly, okay, as you can see there, that line is going through the mountain, so this bit of the mountain is actually putting our vision beyond the point of the lake, okay. So if I was to draw another line above the tip of the mountain, or the hill I should say, it's not necessarily a mountain, we can see that the line of sight that that person is viewing at, okay, is going beyond the lake, and for them to even see the furthest point of the lake, they actually have to look through the mountain. So therefore, position Z would not be an appropriate position to put maybe a picnic spot if you wanted to see the lake, okay, because it said the scenic spot is located here, can the lake be seen, okay. Where would be a better position? Obviously maybe somewhere either on top of the mountain or somewhere along here, okay. So that's just a little bringing some real world scenarios into it. Now, part C, it says AB is the central line of a proposed roadway which is level at an altitude of 50 meters. So what I usually do here is I would write in level at 50 meters. So the road is always going to be at 50 meters. And it says using side slopes of 1:1 for cuts, okay. And the reason we're using cuts is because the land around it, 80, 75, 70, working its way down, okay, is always higher, okay, than the road, okay. So we're just going to be using a cut ratio, okay. So putting that, I'm going to put that information in over here. So our cut ratio is 1:1. And what that means essentially is that for our cuts, I'm just thinking, making sure I'm doing this right now, yeah. For every 1 meter I travel down, okay, or up, I'm also going to travel out 1 meter from the side of the road. And if you imagine the road was here, this section, this is your road bit here, and we're going to travel out 1 meter to go up 1 meter. And that's basically the idea there. And what we're using now, okay, is our little magic number, as I said, was 5 we worked out earlier. So 5 times 1 is 5. And this one is for the one that we travel out. This is the one where we travel down, okay? Or sorry, should have said down or up in this case, and then this one is out. But either way it'll be the same anyway, because 5 times 1 is 5, 5 times 1 is 5. So what we want to do is from the side of the road we're going to measure out in millimeters of 5, okay? So I'm going to just do the top half of the road first, okay? And we know the road is at 50 there, so putting in my measurements, so 50, and it goes up as far as 80. So 5, 10, 15, 20, so that'll be 55, 60, 65, 70, 75, 80. Okay, just to have that done. And I know it's 50 here as well. Is there a pinch point? Yeah, there's a 50 here in the middle of the road. So right there, there's actually going to be a pinch point. Okay, where the land is going to meet the road. And other than that, it's cut for the rest of the road. So this one here is at 55. So I'll plot in that contour line. This will be at 60, 65, 70, 75, and finally 80. Okay, so 55, 60, 65, 70, 75, 80. Alright, and having done it on the north side of the road, I really should put it in the south side as well. So 5, 10, there's only room for 3 here, and 15. So I'm trying to do this, just slipping off my edge of my board here a little bit. Over to the 50. Let's be 55, and finally 60. So same thing, 50, 55, 60, 65. That's as far as it's letting us do it on the map. So what I'm going to do now is locate my points. So at this height here, that's at the 80, so there's a point right up there. The next one is down at 75, then it comes down to 70, 65, 60, 55, goes down to 50, back up to 55, up to 60, 65, there, down to 60, then we're at 55, and finally here pinch point at 50. Now work on the south side of the road, so 50, 55, 60, 65, back to 60, 55, 50 on the road, 55, 60, 65, and obviously you can see here 70, but it's not fitting in on our map. So what I'll do now is I'll quickly sketch in those, so I'll speed up the video. Okay, so there you have it. That there is the earthworks necessary for the road. What we also have to do, just finally, anytime you do earthworks, you have to do this thing called tadpoling. And tadpoling is where if you had a ball, okay, for cuts, generally the ball will start up in the highest part and will roll towards the road. So that's why it's called tadpoling, just because it looks like little tadpoles. In this case, they'll roll this way. Okay, where it's fill, it will be the ball at the side of the road rolling away from the road. Okay, so anytime you have a cut, just put in your little tadpoles and they will roll towards the road. Okay, so there you have it, guys. That there is the part C done for the earthworks necessary for the cuts, and that is the question completed entirely. Okay, once again guys, hope you found that helpful. That's them done.